In this activity, we're going to be solving linear systems by using elimination. Now, we're going to look at an example, and two baseball teams, the Eagles and the Bears, are gearing up for the start of a new season. Both teams purchased new equipment at the same prices. Now, the Eagles spent $975 on 4 bats and 25 balls. The Bears purchased 2 bats and 15 balls for a total of $525. So we're going to determine the cost of a bat and a ball based on the information that we're given. So the information above. So we're going to let X represent the price per bat, and we're going to let Y represent the price per ball. So we're going to take a look at this equation, and if we buy 4 bats, well, the cost of that is going to be 4 times X, because X is the price per bat. And if the Eagles are going to buy 25 balls, well, that's going to be 25 times Y, because Y is the price per ball. So our equation here then is 975 is equal to 4 times X plus 25 times Y. In other words, $975 is the value of 4 bats plus 25 balls. The other equation, we're given that the Bears purchased 2 bats and 15 balls for $525. So our equation is 2x, because x again is the price per bat, so 2 times the price of each bat plus 15 times the price of each ball, which would be the cost of 15 balls, is equal to a total of $525. So now we have 2 equations that are going to make up our linear system, and we're going to solve. We've solved by graphing, we've solved by substitution, and this is the third method that we're going to use, where we're going to solve by elimination. So the goal of elimination is to eliminate or get rid of one of the variables by either addition or subtraction of the equations in order to get a result of 0. Now, as it is right now, we can't add or subtract these equations in order to get one of the variables eliminated. So the first thing we're going to do is rearrange the equations so that they are in the same order. In other words, we need to have here, we've got constant is equal to the x term plus the y term. So we're going to switch this equation around. So we're going to switch left side and right side. And so now we have our constant is equal to the x term plus the y term. So that's the first step. We've got them in the same form, in the same order. And next what we're going to do is try and add or subtract the the equations, but the coefficients have to be the same. So what we're going to do is work with the x terms. Now, you should know that 2x times 2 is equal to 4x. And so we have 2x in the second equation. If we multiply everything in the every term in the second equation by 2, it's not going to change the equation itself, because if we double one side of the equation and double the other side of the equation, then it's the two equations, the two sides, it doesn't change the equation. The left side and the right side are still equal, and we haven't changed the meaning of the equation. So we're going to multiply then the left side and the right side, every term, by 2. And when we do this, 525 times 2 is 1050, 2x times 2 is 4x, 15y times 2 is 30y. So now we're going to replace this equation for this equation in our linear system. So we're going to use these 2 equations in order to solve by elimination. So now that the x terms have the same coefficient, we can eliminate them by subtracting the left sides and the right sides of the equations. So we're going to look at method A, and we're going to subtract these 2 equations. And when we do that, we can look at this as 975 minus 1050. And that's going to be the left side of our equation. The right side of the equation is going to be, we're going to subtract these, so it's going to be 4x plus 25y minus, and we have to use brackets here, 4x plus 30y. So now we're subtracting the left sides of the equations, and we're subtracting the right sides of the equations. Now, 975 minus 1050 is negative 75. And 4x plus 25 of y, we're going to drop the brackets for that, and we're going to distribute the negative through the bracket. So we're going to multiply everything in the bracket by negative 1. So 4x becomes negative 4x, and positive 30y becomes minus 30y. And when we simplify this, the reason this is called elimination, I like to point this out at this stage right here. 4x minus 4x is 0. That's the reason we want the coefficients the same, because when we do this, we subtract the two terms with the same coefficient, then we end up with 0. So 4x minus 4x results in the x term being eliminated, and that's why this process is called elimination. And 25y minus 30y is equal to negative 5y. So that now we're going to divide both sides by negative 5, and we end up with y is equal to 15. So method B it's going to be very similar here, and what we're going to do is subtract each term vertically. So again, we end up with 975 minus 1050, so that is the exact same as what we did before. Now we're going to show the subtraction of the 4x's together. So 4x minus 4x and 25y minus 30y. And when we do this, we end up with negative 75, and once again 4x minus 4x is 0, and 25y minus 30y is negative 5y, and so we end up then right at the same point that we did in method A. So whichever way you feel comfortable, I'm going to be using this method mostly because it seems to be the one that most people prefer. And now we continue. Divide both sides by negative 5 to solve for y, so y is equal to 15. Now recall that y represented the price of each ball. So therefore, the baseballs cost $15 each. So now that we know what the value of y is, what I'd like you to do is substitute the value of y into the two equations and determine what the value of each bat is, or what the price of each bat is. So we're going to sub in to our equations for y equals 15 and then solve for x.